All right. I'm here for CS 240. I'm your TA, or possibly your TA for your section, John. This is my fellow TA, June. Say hi.
Hi, I'm June. I'm the TA for the Monday, Wednesday class.
Yeah, I'm the Tuesday, Thursday TA, and this is the project that we've been cooking up. Call it Mars LE. Basically, what it is, it allows you to create your own custom assembly languages and use them in the Mars simulator. So I'm going to be showing you guys how to set that up. The way that we're going to do that is through GitHub. Hopefully you guys have a GitHub account. If not, then you can definitely figure out how to create one on, Google. I'm sure if you need help, Dom or one of us in office hours can help you out. But once you have a GitHub account and GitHub desktop, you're going to come to this GitHub link, which I'll probably put this on YouTube and I'll put this in the description. What you're going to do is you're going to take this link, copy it, and paste it into GitHub Desktop. Upper left here, go to Add, go to Clone Repository, and make sure you go by URL. Paste it in there. In your local path for the GitHub folder, that's probably what you're going to want. Hit Clone, and it's going to do its thing. We're doing, contribute to John A. Edelman, Mars LE. We're not actually contributing to real Mars. Um, Now we have this, and if we right click, view in GitHub, or sorry, wrong button. We're going to want to view in Explorer. Um, and you see you now have all the files for Marzelli. The main one that you're going to want is this mars.jar. This one is just your standard Mars. And if you'll notice, uh, this one actually has, under the Tools menu, this language switcher. And there's a few languages that are already loaded on here. These are some languages that me and June have created. And what you're going to be able to do is add to this little language switcher tool, make your own languages that have their own instructions. Um, so I'm going to show you a little bit of how to do that. So the most important folder in this project is you have to navigate to Mars, MIPS, instructions, and within this instructions folder is the custom languages folder. And in here, you can see all of the code for all the custom languages. So let's just go over this one that I made. I made a Dragon Ball themed assembly language, which we can look at in VS Code. So when you guys are making your languages, uh, the example code you're going to look at is going to be in here. And then also, another very good source of inspiration and, showing you how to do things is the actual base MIPS instruction set, which is contained in this MIPS assembly file in the instructions folder right here, mipsassembly.java. This has literally every instruction in MIPS and its implementation, so you can see how they added all this stuff. But I'm going to go over real quick my little Dragon Ball language. It's got some fun little instructions in it. And yeah, here's my language. You'll notice that there's a few of these imports that we need in order to actually um, make a language. The first most important thing, the language file, your Java file, has to be created in this folder, in this custom languages folder, or else it's not going to work. Has to be in this folder, and you have to specify package mars.mips.instructions.customlangs. That is like the first thing you do that. I've run into many issues while I was making these languages, and the issue boiled down to I didn't do that properly. So do not repeat my error with my own creation here. And then you got to do the imports. Now, exactly what imports you need depend on what functionality you want from Mars. You can go through the actual code base of Mars itself and poke around to see how all the registers and everything are handled, or you can look at the base MIPS instruction set and learn a lot from that. For this, we're going to need mars.mips.hardware, just the basic, everything from Mars, the base package, mars.util and mars.mips.instructions. Um, but again, the actual imports depend on what you need. Then you're going to make a public class that is the same name as the file name. And important, it has to extend custom assembly, has to extend the abstract class custom assembly, which I have defined in order to facilitate this whole ordeal. So there's three methods that the custom assembly has to override. Pretty simple. Get name, return the name of the assembly language. Get description, return the description of the assembly language. Those two are very easy. And then the real one, the big boy, we got populate, which you have to actually specify all of your instructions in this one. So this is a protected void, and there's an instruction list, which is an array of basic instructions, or an array list. And in populate, you have to add all of your instructions to that. So every instruction you do, you're going to do an instruction list.add, and then you're going to create a new basic instruction object. The first one in my little Dragon Ball language is which is, power up. I figured I should have a kind of how you say, like an analog to load immediate so that we can actually load values into our registers. So here, this is like the format of the instruction. You have the actual mnemonic for the instruction. You have uh, this is not a specific register, but this is just telling the interpreter that it will take a register and that it will take an immediate value. Then you have the description, you have the format. This is I format immediate because power up takes an immediate value. And then this is the actual machine code. Um, so you have to define a custom opcode for all of your instructions. This one I said 00100 because why not? Then this these 5 bits with the F, that's your register. Those are your register bits. These are just filler bits because we only need one register. And then these 16 bits at the end here are for the immediate value. Uh, then the next parameter is you have to do a new simulation code object, uh, which has a method simulate, takes in a program statement, throws a processing exception, and in here, the most important part, you actually have to specify the behavior of the um, instruction. So what we're doing here is we register file.getValue operand 0. Uh, because our first operand is a register, we're getting the value of that register and we're loading it into this variable add1. And then what this is doing is operands 1, that was our immediate value, and we're bit shifting it to get the correct value in that, which we load into add2, and then we calculate the sum, we just add them, and then register file.update register, as in we write into the register T1 or whatever we specified in our instruction, the sum. So ultimately, what this is doing, you give it, when you actually write your code, you give it a register, you give it an immediate value, and it's basically the exact same as li. As a matter of fact, if you look at the code for add I, it's quite similar to this, you'll notice. And in the interest of time, I'm not going to go over all of these in too much detail, but they all have the same basic idea. The actual code behind some of them can be more complicated. If you don't understand this very well, which is understandable, I would say either poke around through the actual source code of Mars itself. There's a lot to look at. Um, you can just go into MIPS Mars and then look at the different Java files, kind of read, especially like globals. You can see a lot of definitions in here. You can see if you dig around in this. I mean, how I actually built this was a lot of digging around in the Mars code. Um, so eventually you can kind of discern the workings of things, or of course, you can come see me in office hours and I can explain some of this stuff to you. Um, but the gist of it is you can define how you write your instructions and you can define what the instruction should do. And if we go and let's say make a new file, let's do language switcher and let's select our language, do our Dragon Ball assembly. Um, we can go into this little help menu and you can see in here all of our little instructions. Isn't that nice? They have the descriptions and everything. Um, So let's just write a simple little program here. I'm gonna say first, you can do how you say strings in these programs, just like you can in MIPS. So let's say power up uh, register 1 by 500, and that will do. Would you look at that over here? Looks like T1 now has a value of 500 because of our custom instruction. Let's do um, something a little more intricate. Let's do, Goku versus Vegeta. Let's do Kaioken times 4. We can load a value of 4 into register T2, and then I have this Kaioken instruction, which multiplies T1 by T2. Um, Now if we do this, you see it follows the behavior we wanted. T1 uh, was multiplied by T2, which is 4, and loaded back into here. And then we can do labels as well. We can do loop. Let's do like power down T1 by 500 per loop. And then I define this instant transmission, which will jump to the statement at the defined label if the register is high enough for you to sense it for the instant transmission, which is, I said 5 or higher. So what this is going to do, it's going to go through this loop over and over again until this is lower than 5. And I'm also going to, so we can actually see the loop, I added a telepathy so we can transmit our message. And that should say hello over and over again. And would you look at that? It does. We have a lot of hellos here. So that's just kind of a basic overview of what you can do with this. I mean, you can do all the things you could do with MIPS. You could define your own fancy instructions to do anything else. I'm going to let June show you some of her assembly languages that she made. I believe she sent over some programs for me to show you guys. Which one do you want to show them, June?
Mario Kart, if that's okay.
Yeah, sounds good. Okay, yeah, June wrote a Mario Kart themed assembly language. So yeah, you guys can make whatever kind of assembly language you want. We are going to drag in this file, which we should have over here, and then go to language switcher, select language, Mario Kart, and you see all these instructions light up. I'm going to open up the code for the Mario Kart assembly and let June quickly go over that, which she wrote. Um, I don't want to. This video is already longer than I envisioned it, so we should be able to wrap this up. Unless you guys go, but I'll let June. You can go over your code as much as you want. Just tell me if you want me to scroll down or anything.
All right, so we got all of our necessary imports. You can reference the other files for them. And cutting straight to the point, we got our get name and get description. You can just fill in whatever fields, or I'm sorry, you can just fill in whatever you want for those. For our first instruction, I made a function called put, which is pretty similar to add I. Like you got your three registers, and the only thing that's really different is the instruction name. And what it does is just it assigns the values to T0, which is our first register. For the basic instruction format, it's the I format, and for the operand mask, I just assigned 11111 for the app code, but you can really choose anything you want for your program. The rest are just variables for like the registers and immediate values. Going down to our simulate function, we have it's very similar to what John did for his instruction, where you just get the value of the first register, convert the correct immediate value for our last 16 bits, and just store it into the first register. And I just have a check here to make sure there's no overflow. And at the very end, you would just store your value into your T0 value. I also have some other functions. Here we have accelerate, which only takes in one register and it moves up the player 3 places. And going down below, we have a break function, which basically just sets a player to 12th place by updating the T0 register to 12. And down below, we have drift, which it bumps you up a place. And then we have, oh, this one's fun. It lets you just simulate rolling for an item. So like in Mario Kart, you know how you can get like a red shell, blue shell. Every time you call this function using roll, it doesn't take in any registers. You can just type in roll and it'll just do a syscall and you'll get a random item. This one's my favorite. It's pretty fun. So yeah, if you guys have extra time, you can definitely just look over this or you can come to my office hours and I can explain it to you. Oh, here's one. Here's an extra one. It's called use item, and basically after you roll for your item, it stores the value inside of v0. And when you call use, it actually tells you that you either like another player with a red shell, blue shell, green shell, or whatever item you got in your random roll. So it's a fun little thing. But yeah, that's basically it for my instructions.
And then, yeah, we can just simulate this, and you can see we got this. Looks like our output is as expected based on our functions here. So that's pretty cool. Thank you, June. We have a few other languages in custom langs. As you may have noticed, you can find all those under Tools, Language Switcher. Yeah, and one more thing that I want to quickly go over is the process of actually creating a new jar file, because I know, putting all this together can be a little daunting. Um, so yeah, you just need to go to the directory, the root directory, Marzilli, go to Mars, go to MIPS, instructions, custom langs, and in here, you're going to make a new assembly file, or a new Java file, sorry. And let's call this one test assembly.java because we just want to get this up and running real quick so we can see how it goes. You're going to drop it in here. And then just to get it running really fast, let's copy um, some stuff from this one, MIPS++. We let's just copy the imports and such. Let's call this one test assembly just to make sure that we've got all this straight. Um, and then of course we're going to override the populate method, override protected void populate, which, yes, let's do instruct. Well, I could type all this out, but that's going to take quite a while. So let's just copy this put instruction, and that should be all for that. Close our parentheses, and it's throwing us some errors. Oh yeah, if it gets mad at you over the package, don't worry about that, um, because it will not affect the actual running of your code. It's just VS Code being strange. If you reboot VS Code, even it goes away. Anyway, I'm going to do Control S to save the file. And now here's the important bit. We open up a terminal window, and then what we're going to do, we're going to go to our Mars LE directory. I'm just going to copy the file path because that's easy enough. Copy address. CD, because I'm on Windows, to Mars LE. And now, the important thing, we have this build custom lang.jar here. The source code is in the .java file, so you can look at that, but the important one is the .jar. So we do java dash jar build custom lang.jar. And now if we just run this, it says improper input provided, because we only need to give one command line argument for this to work, that being the file name of our custom assembly, which in this case is test assembly. So we can do this command, test assembly. You can do testassembly.java, but you don't actually need the file extension. It looks like, oh, well, there's an error because we forgot to change the class name. Good demonstration of the error handling capabilities of that thing. Assembly, save again. Now let's see. Yes, okay. So it will tell you if there's any errors, but it looks like everything has gone successfully. And if we look at our, whoops, wrong folder there. If we look at our folder, then you see we now have a testassembly.jar. This little jar file has gone through all the hard work of building our Java into a jar and moving it into the directory. Done that for us. So now if we open up mars.jar, then we should be able to go to tools, and here's our test assembly. It's got our description, and if we open help, we see that it has our instruction as well. So that is how you go about actually making a custom assembly and getting it into Mars. Now, if this doesn't work, if this jar, this building of the custom language .jar doesn't work, um, there are a few causes for that. One that you should look at is if you're on Windows, your path variable may not include um, jar. I faced that issue when I was making this video, as a matter of fact. So if you do jar, if this says unknown command, then you may have to modify your path variable. But overall, just if you have issues with it, come see me or June in office hours and we will try to help you out. But yes, that is the basic overview of that. Oh, and one thing I almost forgot to mention about the build custom lang.jar, it does not work if you have Mars open. So if it fails, then it may be because Mars is open and you need to close it. So, keep that one in the old dome there. And that's basically the functionality of Marzilli. There's probably going to be expansions that we're going to have to do on this. We're going to have to clarify some stuff. I may need to make another video, me and June. You can always come to see me or June in office hours as well, because we made this so we know how to use it. And there's also going to be, it's a little rough right now, but ultimately there will be a website uh, which you can find on the GitHub page over here. Very early draft of the website right now. Um, but this is going to be like the comprehensive source of information about Mars LA that should. It's currently a little bit out of date actually because we changed a couple things, but I will update this um, shortly as of today's November 9th. But within a few days, this website should be all up to date. I can put an announcement on Canvas once everything's all, freshened up. And whenever I push anything to the GitHub, you guys should be able to pull it if you use the same procedure that I did, and you can keep up to date with any changes. All right, yeah, I guess that's about the basics of Mars LE. I hope you guys enjoy using it. I definitely learned a lot while we were making it, so hope you guys learn a lot as well about assembly language and Java and all these useful topics in computer science. So yeah, thank you for watching.
Yeah, I really hope you guys were able to take away a lot from this video. I know it was a lot of information at the same time, and it can seem really confusing, but you guys have tons of examples, and I'm sure you'll have fun and you'll be able to be creative and make your own languages. Can't wait to see what you guys actually come up with. And yeah, have fun.
For sure, yeah. Come and see us in office hours if you all have any questions, and yeah.